Thank you. So in the next minutes, I'm going to provide to you a short introduction about what XMANAI and what the XMANAI platform is all about. We will look into certain aspects of the architecture, and then we will proceed with the demo, providing you with a detailed walkthrough in different functionalities of the platform. Having said that, what is XMANAI all about? As the acronym suggests, it's all about explainable AI in manufacturing, how to make AI understandable. So in this context, although we have a very focused scope related to manufacturing, our whole approach is related to how we can help make AI more explainable to different stakeholders, leveraging different data and AI technologies, ranging from data management, data sharing, data security to AI lifecycle management technologies that we will see in a moment. The target users for our platform are data scientists and data engineers, but also business and technical users that can also upload data, and they are interested in gaining new insights out of explainable AI. Why our approach is different? Because our approach is really focused on reinforcing trust in AI through explainability. We are trying the different problems we're trying to solve that are not within the scope of this webinar, but in general, I'm just mentioning them in order for all the audience to have the broader perspective of why we provided a platform that was really related and focused on explainable AI. The purpose has been to help data scientists that work on specific problems to collaborate better with business users, with technical users, and help them understand why an AI system made a specific prediction. This is a very common question that one encounters by the end users. Why should I trust you? Why did you make this prediction? What were the factors, the features that led you to provide me with a specific prediction? And why didn't you provide, you meaning obviously the AI system, why didn't you make a different prediction B for the same circumstances? Or what should I change in order for the system to decide something else? All those questions are really related to why we put a lot of emphasis on explainability. We have been working. XMANAI is a research and innovation action that was funded under the Horizon 2020 program of the European Commission, and in practically 7 days our project is about to end. So all the development activities, the demonstration activities have proceeded a lot, and the landscape has totally changed in respect to what happened when we started the project almost more than three and a half years back. The landscape related to AI, related to data technologies is continuously evolving. You can see just a screenshot here regarding the latest view, the latest landscape that has been provided last month practically, related to open source and commercial solutions related to ML and AI. Even though explainability techniques are part of certain AI platforms, they do not have yet a category on their own, even though all those categories and that the different technologies related to data and AI are continuously evolving, and we have been seeing the ML observability aspects to emerge. The explainability part is not yet there, even though in some cases it is part of the functionalities of some data and AI platforms. In the way we position and we view explainability, it's something that we tried, it was the main differentiating point in our whole approach. And looking at our architecture consists of three conceptual layers. In the middle, we have the what we call the centralized cloud infrastructure. Practically, we have a platform, the core platform, where that is the main point of entry of any user to XMANAI. In case a stakeholder is willing to upload their data on the centralized cloud and the infrastructures that the technical partners of the project have offered, then secure execution clusters are spawned on demand per organization in order to execute the data and AI pipelines, explainable AI pipelines that have been configured on the core AI management platform. In case a manufacturer, in our case, in a stakeholder in general, is particularly concerned about the security aspects and do not want to share their data through the centralized cloud infrastructure we are offering, there is an option for them to install part of the platform that refers to the storage functionalities and the execution functionalities mostly. They can install them in their private cloud that they host and they have full control, and they can we can ensure that everything that they have configured on the centralized cloud infrastructure works seamlessly between the centralized cloud and the on-premise environment, and in a way that is not really transparent to the end user unless he looks, let's say, on a very, very specific part. In the demo, we will see in a moment, later on, the whole demo will be provided on the centralized cloud infrastructure, since we do not have in general access to the on-premise environments of our business users, of our demo partners. Apart from those two layers that essentially constitute the core of the XMANAI platform, we have built a number of manufacturing applications that target specific problems that our demonstrators faced, and those manufacturing apps are self-standing. They are essentially different dashboards, mobile apps and so on that are offered to the business users. They present the data, the results of and explanations associated with specific explainable AI pipelines that are running on demand on the XMANAI platform, either on the centralized cloud infrastructure or on the on-premise environment. The architecture, as I anticipated by saying that we're looking into a wide range of data and AI aspects, it consists of many different bundles and a significant number of components that constitute each bundles. From the bottom, we have the data collection and governance services that are all about how the data are admitted to the XMANAI platform. The data handler, and in particular the API data harvester and the file data harvester, are responsible for uploading data either as files or through APIs to the XMANAI platform. Obviously, at any moment, data that have been uploaded can be also exported, and any file that has been uploaded is treated not only as data that eventually are stored, but also as dedicated files. The data can be anonymized through a tool that can be installed locally in order to properly handle the data. And there is also the provenance engine that allows us to trace the different versions and the changes that are performed on the same data set over time. On the data are stored on the scalable storage services, and the data can be manipulated through the data manipulation engine that has two parts. One part, that what we call the interactive data exploration and experimentation tool, is practically Jupyter notebooks that have specific templates that we are offering in an out-of-the-box manner in order for the data scientists to explore and experiment with their data, and a data preparation engine that offers specific data manipulation functions that are becoming available through the pipeline manager, to which I'm going to refer to in a moment. Within the data manipulation services, one can find the knowledge graph manager as well, that is responsible for managing the data models that are underpinning the operation of the XMANAI platform and contribute to gaining what we call data explainability, understanding the structure and the semantics of the data that are ingested on the XMANAI platform. The pipeline lifecycle management services that lay on top of the previous bundles consist of the pipeline explainable AI pipeline manager that allows the users to design explainable AI pipelines, but also to monitor the execution and the logs of any pipeline that has been configured. The model engineering engine consists of a number of components that are related to explainable AI models, as the name suggests. It's all about creating training and inference scripts that allow the users, the data scientists, to build the models they need. The model explanation engine allows the user to combine different explainability techniques with the core models they are offering in order to get the local or global explanations they need, depending on the technique they have selected. The different runs for a model that result into different experiments are tracked through the experiment tracking engine. For security aspects, to avoid data poisoning, for example, just an indicative example, the model guard is in place, and the user can configure different models that can run in order to monitor different model security aspects. And the models catalog includes a number of pre-trained but also baseline models that have been created to solve different problems. The explainable AI execution services bundle consists essentially of the execution and orchestration engine that is responsible for running any pipeline, anything that the user needs. And ensuring, obviously, that according to the configuration that the user has provided, and ensuring that the outcome is properly stored on the scalable storage services. The explainable AI insights services are all about the visualization engine. We're talking about the results visualization engine, the results that come out of an explainable AI pipeline, but also we're talking about the explanations that may be provided that can be visualized in a more data scientist oriented manner, but also visualization capabilities are accompanying additional components that I have already described. The secure sharing services are practically all about a marketplace we are offering that allows stakeholders that are on the centralized cloud infrastructure and want to share different data sets, different results or models with other stakeholders. This is possible through the marketplace that allows the user to provide the different metadata in order to describe their data assets, and a full, let's say, infrastructure that handles fully online smart contracts that provide the terms of sharing for a specific asset between the different users. the platform management services. I'm sorry, I'm trying to speed up because I have taken more time than I had initially, let's say, planned. The platform management services are all about controlling, ensuring the user management for sure, and the organization's management, since organizations get access to the XMANAI platform and all the users belonging to an organization can work collaboratively together. The identity manager is the component that handles authentication and authorization on the XMANAI platform, while the data access manager with the policy editor and the policy engine controls who can access a specific data asset depending on the preferences of the data provider that has uploaded a specific data asset. So explainability in our case is viewed from 3 different perspectives. The data perspective that allows a user that uploads data to understand the structure, the data types, the semantics behind the data through different components that are part of the XMANAI platform, but also interactive data exploration in order to dive into what the data are all about. The model explainability that allows the data scientists in particular to gain more insights on the inner workings of a machine learning or a deep learning model, feature importance. Surrogate models can accompany the initially selected model, or directly interpretable models can be also selected and used. When it comes to results explainability and understanding what the result is all about, there are different, let's say, options that can be leveraged, from counterfactual explanations, post hoc explanations, or elicited local explanations that are produced with the help of the model explanations engine, and in the end of the day they are visualized for the end users based on their exact needs through the manufacturing apps. At this moment, I think I'm going to provide, let's say, the floor to our colleague Dimitris from UBITECH in order to proceed with the detailed walkthrough on the platform without taking any further time, let's say, on the introductory part. So I'm going to stop sharing. I think I have already stopped sharing my screen. So Dimitris, please go ahead with the demo.
Hello, can you see my screen?
Hi, Dimitris. Yes.
Okay. So, hello everyone. I'm Dimitris Boura. I'm a senior data engineer in UBITECH, and today I'll be giving an overview of the XMANAI platform. The platform, as Fenareti mentioned, the main users are business users, data scientists, and data engineers. The business users are using the platform in order to improve operations, decision making, and customer interactions. They are experts who employ the AI tools in order to do tasks like data analysis, predictions, customer segmentation, and the role is to verify the result accuracy and the relevance to their business needs. The data scientists, meanwhile, focus on constructing AI models to ensure accurate results. They develop algorithms to tackle specific business challenges, whereas data engineers are concerned with data gathering, preparation, model deployment, and enforcing policies on uploaded assets. So I'm going to log in right now to the platform. Upon login, the user is presented with the core operation groups organized in such a way to fulfill the platform's workflows. The user can access the data harvesting operations that enable the user to create new datasets from existing files or APIs. So by clicking here, can you see the upload via API from the file, if someone can?
Yes. Dimitris, we can.
So I just to confirm that you can see the pointing of the mouse. So you can import the data from file or from API, or in the on-premise case, you can prepare them locally. Furthermore, you have experimentation operations by clicking on experimentations. These operations facilitate exploration via Jupyter notebooks of the data. The pipelines, where you can manage your models and create pipelines. Furthermore, there's the asset management operations, where you can manage and view your data sets, the models and the results, and also your initial files, and also browse the XMANAI data model. The catalog operations give the user the ability to search for the assets and manage an organization's contracts. Finally, I'm logged in as myself, but there's also a view for the administrator that can enables the administrator to add organizations and delete organizations or add users to the platform. Now, the first component that we'll explore is the Knowledge Graph Manager, whose interface can be found under Asset Management, and basically is the visual representation of the XMANAI data model. So let me click. Let me go to the overview. So this graph represents the data as it's structured and how the data correlates with one another. We have categories, which are divided into concepts. So the categories, as we can see here, and we can click and see a specific category, are the blue dots, whilst concepts are the yellow dots and the relation with the category. So if I double click into, for example, a concept, which is the 3D scanner, on the right I have the description of what this concept is about and its properties. The red dots, as we can see here, are the properties. These properties, if you remember for later on, set laser angular width, CMOS, KMOS, and whatever, and K and J and I, are all properties of a file that we will be able to upload afterwards in order to create a data asset within the XMANAI platform. And concept is also related to other concepts, as we can see here. So this orientation, for example, is another concept that has its own properties. Now, this is a base model of the XMANAI data model that's already been created. So users may require to change some specific concept and add a property, a new concept, or even a relationship between concepts. This is facilitated by using the new request UI. For example, I would like to add a property. I will have to give a property a name. I need to give the information about the data type, also which category it's going to be under. So, for example, 3D representation, which will bring up the concepts under the category. So I can choose 3D scanner, for example, that we had just seen earlier. Furthermore, we can add a description. And finally, what's important is to add a reason that why we require the property, the concept, or the relationship. This is used in order for the administrator, not the platform administrator, but the Knowledge Graph Manager administrator, who is a senior analyst, to understand, to better understand why this is required by the user, and accept or decline it. A reason to decline it, for example, is because there is an overlap with another concept. So he'll respond back with acceptance or to decline the property. Now, I won't create one, so let's go back. As I said, this is the overview of a data model of XMANAI. So this is something that's kind of up to date for now. So what we will do now is create and upload the file in order to create it as a data asset within XMANAI. So under asset management, if we go to my files, we have a card representation of all the files that we have in our organization. So these are files that I have already uploaded. The user is here, whereas Dimitris Boura, another user in our organization, has already uploaded some files, and I can view them. We have edit the information and delete button for the file, and we also can upload a file. So let's go and upload the file. So I'll upload this file. It's successful, so it will reload, and sure enough, here's the file. Now I can go into the file, and rename it. I can see the information about it, when was it uploaded, when it was created, and when it was modified. Here's the Providence engine at work. You can see that it's version 1. And from there now, we need to create a data set from it. So there are two options. Well, there's one option, as in regards to files, it's a file data harvester, but there are two options in order to click and create a dataset. We can either click here, add dataset, or we can do data import and go dataset from file. So the file data harvester, which is a cloud component, in this case will load, and we can choose a file. Let's find the file I just uploaded. If we select it, the user, here are the properties as described in the data model. That's why I said, if you can remember, there's a laser, CMOS and JMOS. We accept that this is a table head. We will then proceed to create the mappings to the model. So this is KMOS, right? This is JMOS, and the last one, and that's okay. So we submit this. The file data harvesting operations will check for alignment of data types, and it will be a warning if there's a problem, and we'll stop the uploading. So I'll create a dataset called demo. So the dataset has been successfully saved. We'll close this. And now we can view this dataset in my datasets. My datasets, this is the demo that's just been created today, just now. We can edit asset details and give a description. Add possibly keywords for how long it will last. I don't need to add all this. Actually, I do, but let's cancel it. We don't need to do it right now. We can see the types and the version again from the provenance information, from the provenance engine. We can control access. We can set a policy for this. I think it's because it's incomplete, so I won't. Sorry for that. Anyway, the dataset is ready. Now, what can we do with the dataset? Obviously, we can experiment with it. So the next step in our journey should be to experiment. We can use experimentation engine. We can do data exploration, and we can do machine learning explainability. By creating a notebook, we can create a Jupyter notebook that's available from the platform. So let's make this click. Give it a name, my test. Notebook. We can say that we want to explore the data. There's no need to create anything else. We can launch it. And now we have a Jupyter notebook. In order to select, we can select the specific kernel. So what I'll do is copy some Python code in order to speed things up. Sorry for that. Oh. I'll take a So what I'm doing is I'm importing some Python libraries. I'll do an ls to find the files and then run based on the files, read the file and plot some history regarding JCMOS and JC laser. So if I run this, I can see here the plots for both CMOS and JMOS. Now, this is something that an experienced data analyst that writes Python code can quickly explore his data with, and also experiment using some kind of model. After that, the main focus will be to look into the pipelines and create models via the model configuration. Here we can choose to upload a model or use a specific model that we've already uploaded. For example, we have created a random forest model, but I'll go through the process of uploading a model on an XMANAI tool. So uploading a model, there are 3 files that are required. First of all, we need to create a name. So this will be a demo again. And we will need to create and drop specific files that a data analyst will have created as a model. So give me a second. Downloads, I think I've got some models here. The first, so we need the training, the inference, and the metadata described in the model in order to create a new model, to upload the new model. So they've successfully been uploaded. Now we need to upload a tool for this model, the explainability tool. Give it a name. And again, these tools have been provided by someone and shared, so we can use them. 1 minute downloads. So now we've uploaded the model and created a tool. We need to create a new training session. So let's just check that the data has been selected. So the models that we have created should be somewhere here. Here it is, sorry. Demo 23rd. So this is the random forest model that we have created. We'll consider next, we'll create a technique, select a validation technique. We select a performance metric that we need to check upon. We'll use a tool that we have created. Here it is, demo 23/4. And this will provide an explanation type, a visual explanation. Sorry about this, 1 minute. So create tool, and now we will create the session based on the model we have created. So the model is a random forest that asks a question. It's hybrid. It gives some kind of hyperparameters that we have selected. It gives an overview of validation technique and also the performance metric, which of type R2. So we need to create a session based on this. Now, having created a session, we can now proceed to create a pipeline based on this. So let's go into pipeline management. Here we can view different pipelines that we have already created as a user or as again from our organization like Dimitris down here. The different kinds of I'll start by creating a new pipeline. This will be the webinar pipeline. We can give a short description. It has a random forest description. Okay, I'll be brief in my description. And now we are presented with a design tool that allows us to bring in a data set, create a train a model, and then create an explainer. So let's do that. Here's a data set. The data set we're going to create to read from is the demo 23. This is a demo thing that we created. Yes, here's the points. We can then add explainability. So we need to train the model first, not explain it. So let's train it. The way to do this is to read from a data set and then specify the session that we're going to run at. So demo webinar session was a session we just created. And we can see here that it's a regression, random forest, and the type is hybrid. So if I click save, this will link the read data set with the trained models. And finally, we want to create an explainer about this. So let's add an explainer. And the incoming steps again, in order to link each other, is the trained models and then the session that we need to create. So by saving this, I think this is our first pipeline. Oh, maybe I didn't save something here. Okay, sorry about that. So now we can execute this. So now we can execute this directly, submitting it for pipeline. So let's do that. The pipeline has been submitted. Now we can view the process by going into the logs. Let's put auto reload. If we see here, the data has already been read by the pipeline. It's now in the process of training the models. There's been no warning, but I think we're okay. And it has been completed. So basically the whole process has been run. Now in order to speed things up, what we will now do is after the explainer that is stored in the asset store, we need to perform an inference and then export the result and explain the model output. So let's go back to pipeline management. I think I have something already ready, so I don't have to change much stuff. So this is a pipeline that we have already created. It's the data set that we will read now only the X in order to perform inference. What we need to do is run on the same session, obviously. So we need to change this into the demo webinar session. And also perform explain the output model by using also the exact same session. Let's save this. And finally, we need to export the result. And this is okay. We need to change the result to, I don't know, webinar. save, and we can execute this pipeline. Go through to view. As you can see, we can see the previous runs also of this pipeline. I'm not quite sure why that failed, but it may have to do with something I did not save in the pipeline. I won't go back, honestly. Let's go back. Upon successful, anyway, upon successful results, we can see the results exported in my results. The my results page encompasses all the results from different runs. Here we can see the results for the webinar and the prediction. This one was the previous one that I ran this morning just before, which worked. So let's go into that. We can fill in the metadata and add a short description and the version, and also say again what kind of license is required. We can add a license, for example, for the result. We can say that it's business, and okay, so we need to add a few more things. Now it's available. Now I can add access, I suppose. There's something wrong with the policy manager, which is weird. So my files, my data sets, what we can, my results, what we can do is check the visualizations regarding our results. So let me go back to the webinar visualization. We can see the results here, and we can choose a plot. Okay, this was a demo, so there's not much to see, so I'll use a table. But in another case, it could be a pie chart, it could be a time series or a scatter plot. We can use what we want to display, and then we can finally plot the visualization. And then we can save this as a result. Now, having viewed the results, we could also delete, visualize, and manage the asset policies. What we can also do is share them. So the catalog, in this case, provides the ability for the users to search available assets in the marketplace. So here we can see that the two example data sets are available, and also the asset user demo. We can go into it, and actually no, because this user is not, I'll just look in as user one for a minute. Sorry about this. So let's see what sharing agreements this user has. This user has just requested, I did this earlier, he requested to buy an asset, which is the random forest result that was generated earlier by myself, and also has two active contracts, which we can review here. So there's been a request to the group 2 from the user 1. The request has been reviewed. There's been the contract has been created, signed, and is active, and it's effective since 2022, and the duration is forever. As I said, finally, if I log out, there's also an administration view. Here, this is the super admin dashboard, where the administrator can review organization requests, can view the registered organization, can activate and deactivate it, and also add or support different service endpoints. That's more or less the platform. If you have any questions about the platform, please let me know.